Let's take a look at part A. So, part A. A highway on-ramp is raised to 30 meters. The suggested speed of it is 25 meters per second. Yeah, 25 meters per second. What is the force exerted on a 1,500 kilogram car if it obeys the speed limit as it travels around the ramp? Okay, so what are some things we know? Think our list.
Mass.
Mass, what's mass? 1,500. Good, what else? What? Radius, good. What's the radius, Maria? Not 10. 30, right? Okay, what else do we know? Velocity, what's velocity, Kim? 25. So, how do we find the force? Good. So, the force centripetal equals mv squared over r, right? Right? Force centripetal is mv squared over r. Right? Equation 4. Right? So, plug in what we know, and we can figure out the force. So we plug in 1,500 and 25 and 30. So force centripetal equals 1,500 plus 25 squared plus, or divided by 30. I said plus, multiply. What's the force?
31,250.
31,250. Sergio, you said you couldn't do it. Sergio, who'd you copy? You said you couldn't do it.
Well, see what happened was I used the calculator and whatever is left in my brain.
Whatever's left in there, you figured it out?
Yeah.
Well, hopefully you don't use it all up because we're needing that for the test too, right?
Yeah.
All right. So any questions about how we got 31,250? Somebody's saying, okay, we've been doing this for 4 days, 5 days now. Can we do something different? Right, Amina?
We can keep it the same.
Keep it the same?
Yeah.
Do the same thing for the rest of the year every single day?
I mean, not for the rest of the year, but
Okay, just for a little longer. All right. Well, how about like 30 seconds longer? Okay. All right. B. What would happen if the car increased its speed to 30 meters per second? Well, before we go on to B, let's talk about A a little bit more. We skipped this part. Oh, wait, sorry. We didn't skip this part. But it says, what is the force of friction exerted on the 1,500 kilogram car, right? But this equation finds force centripetal. So what's the relationship between that force centripetal and the force of friction? They're the same, good. Because as the car goes around its turn, now the on-ramp might not be completely circular. This might just be the portion of it that's circular. All right? It might go on this way onto the highway. It might come off of just a normal surface road right there. Okay, but there's a part of it that is circular, just like every turn. There's a part that's circular. Okay? So that part that's circular might be right here. Okay? There's kind of our outline circle. You guys see it? You guys see it? Maybe I picked a bad spot for it, but I think you guys get the idea. As the car goes around this circular portion of track, its velocity is tangent to the circle. Its acceleration is which way? Towards the center. Now what causes that acceleration? Centripetal force causes acceleration. But what causes the centripetal force? What causes the centripetal force? If this was a mass on a string, what causes the centripetal force? Tension, right? If this is the moon going around the earth, what causes the centripetal force? Gravitational pull, right? If this is a car going around a turn, what causes the centripetal force? Friction. So this force right here, that is the force of friction pointing that way. It's also the centripetal force. Does that make sense? Does that make sense, guys? Okay. So, B, what would happen if the car increased its speed to 30 meters per second? So now we can move on. We know if the force of friction is 31,250. All right? Now, do you think that's the maximum force of friction? I think it's the maximum force of friction needed to sustain this turn?
Nope.
You think the highway safety people would do that to you? The velocity they post on the sign, you think that's the maximum velocity you can have going around the turn and still make it? I'm not trying to challenge you, I'm just asking a question.
I think you can go.
Okay, you can probably go a little bit more, can't you? Okay, but let's for a moment assume it's icy or wet. Okay, or let's for a moment assume that is the maximum velocity. Okay, Let's assume that 25 meters per second, that's the fastest you can take this turn and maintain that radius. All right? So what will happen if we try to negotiate that turn at 30 meters per second?
Well, you're not going to make it because it's a bigger number.
What's going to be a bigger number?
The force.
What force?
If the car's going 30 meters per second, the force friction is going to be bigger than when it was going 25.
Will the force friction be bigger?
Yeah.
Because remember I said let's make the assumption that this is the fastest speed you can negotiate that turn with, right? You can negotiate that turn, right? So what does that mean about this force right here? This is the what? The force of friction. That's the largest force of friction possible. Because those highway people that make up those speed limits around the turns and design it, they use physics to figure out the force of friction exerted between the tires in your car and the road. All right? And they have a safe region that isn't the maximum force of friction. Like I said, let's assume that this one is the maximum force of friction. That's the maximum force of friction. So that's the maximum force of friction. How much friction can be applied to the car at that spot? 31,250. So if we increase the velocity, Sergio, you said a number gets bigger. What number gets bigger? No! Centripetal force, right? If we increase to 30 meters per second, the required centripetal force turns into what? 1,500 over 30. What am I multiplying by now?
30.
Not just 30. 30 squared. Right? 30 squared. 1,500 times 30 squared divided by 30. What's that equal?
45,000.
Exactly 45,000? Okay. So will the car have enough friction to negotiate the turn? We said this was the maximum force of friction, right? Will the car have enough friction to negotiate the turn? No. Okay. So if we're approaching that turn at 30 meters per second, the radius is 30 meters, all right? We will not have enough friction to negotiate that turn because we said the force of friction was that, so it is less than our necessary centripetal force. So what do we need to do to that centripetal force? What do we need to do to the centripetal force? Lower it. Good. If we are going to make this turn as the driver, we need to do what?
Slow down.
Slow down. That's one way, right? What's the other way?
Hope that something happens so you can make it.
What's another component of this equation that I can change? mv squared over r. What's another component I can change? We can change the mass. So while I'm going around the turn, I'm going to start throwing passengers out.
Wow.
Not socially acceptable, right?
Not really.
Okay. Just going to open my trunk and let all my groceries fly out, right? Not very cost effective. What's another way I can do this? So changing mass is a good idea. We can't throw people out of our car. Not safe, right? We said we could slow down, or we could do what? Change the radius. How will I make the centripetal force requirement decrease by changing the radius? Richard? Make a wider turn. Good. So if this radius, when you say make a wider turn, what does that mean? What does that mean for this 30? It gets bigger. Okay. So what I want you guys to do, I know it doesn't say up here for B, but I want you guys to find the radius that we have to turn at. Okay. It shouldn't take too long. All right. We know what the friction is, right? Right? We know what the mass is. We know what the velocity is. We need to find the radius. Thank you, Sergio. Okay. I'll write the equation up here, right here for you. So, if you haven't got it already, that's fine. I'll help you out.
Oh, I got
You
it.
already have your equation written down. Just check to make sure that yours agrees with what I'm writing. So I need you to solve for what right there? All right. calculator, Derek? 24?
4.
4? Who took 4?
Wait, I got.
Kevin, what calculator do you have?
I have my own.
Okay. Derek, you use Kevin's calculator then. Don't break it, he's watching. Let's go. You're just whistling. You did. All right. So what's the radius? 43.2. So is that a good Richard's wider turn idea? Is that a good Richard's wider turn idea? Okay. If you did not get 43.2, this is how you do it. You multiply both sides by r. Right. So then your r's cancel. Right. Then you divide by 31,250. So then our new r equals 1,500 times 30 squared over 31,250. And we can plug that in. Are you sure you got 43.2? Yeah? I got 2 people that agree. So, that whole 5 over thing that people think is okay. Does that work here? I know meters per second, miles per hour don't directly convert to each other, but the idea is still there. All right? If you are driving faster than the posted speed, okay, especially in conditions like we have where it's icy or wet, right, then you are liable to have your car need a bigger what? Radius. So if the car right here needs a bigger radius, where is it going to go? It's going to go this way.
It's gonna hit the wall.
Okay? Could hit the wall. Could slide off the on-ramp. Right? Right? That's why it's important to follow those speed limit rules. Okay? Especially when you're doing what? Turning. Okay? Especially when you're turning. Okay? Because then you are really depending on the friction and the physics involved. Alright? It's a good idea to remember right now. Alright, let's look at C. You don't drive yet. Alright, well, yell at your mom then. Ma, slow down. We're going to slide off. I don't want to push the car out of the ditch. Alright. So, if the pavement is covered in ice and the force of friction exerted on the car is 25% less, what would happen if the car were to travel the on-ramp at 25 meters per second? I hate it when it does that. I love Prezi, but I hate it when it just zooms out on me. Alright, so what would happen if the car were to travel the on-ramp at 25 meters per second? And what would the driver have to do to successfully navigate this ramp? Okay. So, I want you guys to answer these 2 questions. Alright? Now, if the force of friction is 25% less, that means I take this number, 31,250, and multiply by what? 0.25 or 0.75? What's 25% less than 100? 75. If I give you 25% of my $100 bill, I have 75 remaining, right? Right? So that means I multiply 31,250 by 0.75, right? So that's a good place to start. So 31,250 times 0.75, that is the new force of friction, right? Where does force of friction go into this equation? Where does it go into this equation? The FC, right? Okay, so that'll help you. That'll help you with the second part. All right? Give it a shot. try not to talk for the next 3 minutes unless you need help. We'll go forth. What's your new? Less than a minute.
Mr. Ranch,
Yeah.
what do we need to do in the second question?
The second question, you have to figure out how the person will make it around the curve. So what do they have to do? Okay. Okay, so the first one. What would happen if the car were to travel the ramp at 25 meters per second?
They wouldn't make it.
They wouldn't make it. Where would they go, Sergio?
They'd hit the wall or whatever.
Okay, they'd hit the wall. They would somehow move which way? To the inside or the outside?
Outside.
The outside. All right. So if they tried to, let's say this is our curve right here. Here's the car.
You say carb?
Car.
I said carb.
Here's the carburetor. That wheel's kind of funny looking. All right. So if this is the curve and the car is going this way, right? There's its tangential velocity. Here's the acceleration. Right? What's going to happen to this car? It's going to move which way? Towards the outside. The car, instead of following this path right here, is going to end up following a wider path. Right? So, to someone who doesn't really understand what's going on here, they might assume the car is experiencing a force which way?
To the left.
To the inside or the outside? Outside. Someone who doesn't really understand physics might think the car is experiencing a force this way, and I'm drawing with a dashed line because it's a fictitious force. Okay. It's what the fugal force. Okay. A lot of times that's the force people attribute to the water staying in the bucket. And it is, to an extent. Okay. It is a fictitious force. The reason why this force, okay, air quotes, exists is because of the inequality between the centripetal force needed and the force of friction provided. If this is the case, right, force of friction is less than centripetal force, where does it move? Where does the car move? moves outside, right, it experiences that fictitious force. But all it is it's because the force of friction is less than the centripetal force. Okay. So part 2 said, how could they navigate this turn? So how could they take this force of friction and make it equal that centripetal force? What do they need to do?
Increase radius.
Increase radius. Good. So we can make a wider turn, right? If we increase the radius in this equation, what happens to centripetal force?
It decreases.
Decreases. Perfect, right? What's the other way they could change that centripetal force?
Velocity.
Velocity. Do what with the velocity? Decrease the velocity. Okay. So if this were you, or if this were me, right? If I entered the on-ramp and I thought, oh my goodness, I'm going too fast. Okay? Number 1, don't slam on the brakes. Bad idea to get started. Okay? If you have the room, widen your turn. Don't change your velocity. Okay? Take your foot off the gas, widen your turn. If you do not have the room, take your foot off the gas and gradually hit the brake to slow yourself down. The reason why, in icy conditions and in dry conditions, okay, your car does not behave like one solid mass. It can behave like multiple masses. Usually the front set of tires and the back set of tires behave like 2 masses. All right? So if I slow down my front tires, which typically we'll have front-wheel drive cars, so you hit our brakes, those are the ones that respond quicker. All right? What happens to my back tires? Okay, they go which way, Kevin? They experience this fictitious force outward, then what happens to my car?
Spin.
Starts to spin. Okay. The way you get out of that, you hit the gas and you speed up a little bit. All right. So if you have the room, widen your turn. If you don't have the room, then you need to start slowing down. Okay. If you feel your back end start to fish out, or fishtail is what they call it, okay, speed up a little bit. Don't hit the brakes. If you hit the brakes, then you fishtail more. All right. So there's your little driving instruction for me. You don't get that in driver's ed, do you?
Nope.
All right. So let's figure out. We said there's 2 ways. R and V, right? Right? Did anybody find this radius?
Yeah, 40.
40?
40.
Okay, so let's figure that out. So our new force of friction was what?
23,037.5.
23,000. So that's basically what our centripetal force has to equal. Okay? So there's 2 ways to do this. We had 23,437.5. That has to equal mv squared over r for us to make the turn safely. Okay? At 25 meters per second and 30 meters as a radius, we have 31,250 over here, so it won't be enough, right? So that's why we had to decrease the radius. Increase the radius or change the velocity. So some of you took this approach. You kept your velocity the same and solve for the radius, right? Right? Who took that approach? Okay, 5 of you. All right. So to solve for the radius, you multiply both sides by r. Then you divide by 23,437. Those r's cancel. And you end up with the radius equals 1,500 times 25 squared over 23,437. And what did we say that was? 40? Thank you. So we can make the turn at 40 meters, right? That's one way, correct? What was the other way? What was the other way? Instead of changing the radius, we can change the velocity, right? So if I'm changing the velocity, once again we have 23,437.5 equals mv squared over r. Oops. Need to plug things in. Can't solve for 3 variables. 1,500 v squared over 25. Right? Was it 25? No, it's 30. 30. What am I doing? 30. 25 was the initial velocity. Okay. So now I'm solving for v, right? I'm going to multiply by 30. So we have 30 times 23, 437.5 equals 1500 v squared. Now what? We're going to divide by 1500. And once you get that, what do you do to that? Square root of it. And what's our new velocity?
21.65.
21.65. So either of those changes will help you navigate the turn successfully. All right? Does that make sense? Does that make sense, guys? Okay. Are there any questions? Okay. I don't want to be confused here. This idea of centrifugal force, centrifugal with an F, not centripetal, is this real or fake?
Fake.
Fake. What causes this?
Inequality.
Okay, an inequality. Okay, in this case, it's our force friction being less than force centripetal. Okay, that's what caused that outward force. All right, does that make sense? Or, I guess outward fictitious force. Okay, it's basically the car adjusting its radius to make these equal. All right, any other questions? All right, nice job today.